Hey everyone, welcome to LEAP, the League of Emergent Architectural Practitioners. I'm Stephen Corliss, your host and mentor. Today and tonight we're going to explore 3D printing in architecture. So maybe you've explored in school or out of school printing little PLA, plastic toys, or little architectural models. I did that. I think a lot of us who are at least probably watching this video because you're interested in 3D printing or in architecture school experienced 3D printing to some degree. I will say back during my academic years, around 2008 to 2010, we were still playing around with the glue and resin printing, and so the technology has evolved a lot, and I think there's a lot of promise in integrating 3D printing into actual practice. And this video is going to be a little bit about how we are looking at how design can change, or product specification, or just the overall construction process being changed. So let's jump into it. This is not going to be a scripted video, so I apologize in advance for any just mishaps or things like that. So let's jump into just sharing some screen. The first thing I wanted to talk about is Icon. So if you've heard anything about 3D printed homes, there's a few large players involved. Icon is one of them, and most recently they're printing 100 home development over in I believe it's in Texas, and they've got a great system. That printer that they're using right now is the Vulcan, so that should be up on the screen here. Looks like an Apple product. It's not, but this is the Vulcan. So this is, I'm not sure which generation, but it's their gantry style printer that's basically set up on a track, and it's going to be using this print head here to just slide back and forward to basically print a building out of mortar. So it's not concrete. The material makes a difference, and so we'll review that in a moment. But the reason why it makes a difference is because you're basically sending this mortar through a pump to the print nozzle and printing a digital file in place. This is their next generation printer. It's called Phoenix, and this is more like a robotic arm that you would see, like a KUKA robot arm that we are able to program, or it's more familiar probably in the car manufacturing setting, but it's being used here with the print head to pump the mortar through the nozzle and being able to print what you're seeing up on the screen here. Some very impressive results. Very typical of the 3D print is sort of the linear striations that you're seeing up on the screen there. We'll jump into the technology here. I mentioned the material that the 3D printers use. So the reason there's a lot of interest, I think, in the emergent architectural community is it puts design and manufacturing and construction back in the hands of architects, designers. Not to belittle or take the authorship of construction away from any of the trades, I will go on record saying that I think it's extremely important that we support the methods of construction that we have. There's a time and a place for everything, but that's not to say that this technology can't become part of the repertoire of tools that architects, designers, and tradesmen, contractors have to fulfill a certain design. And so what we're already noticing is we have some capabilities in terms of texturing, curvature, things of that nature that, they're not necessarily new, but they can be achieved quicker, faster, easier. And so there is something in that capacity that, as designers, it is an interesting new technology that we can play with. So there's a video here. I'm actually not sure exactly what it is. I will be crediting all of this to Icon, but it looks like it's just basically showing the earth or the mortar and the material. So the material I wanted to mention from Icon, they have a proprietary mix that's called Lavacrete. And their Lavacrete, clearly they've worked very hard to get a material that has the consistency that you're seeing. And again, the consistency able to reproduce textures and things, curvatures of things of that nature. So if I just scrub through the video here to make sure we're kind of getting applicable content. It's basically just showing over and over the idea that their mortar is a special material. So as of recent, or I'm not sure how recent, there's been a lot of conversation about the ecological effects and the carbon effects of concrete. So we will say that because mortar is a part of concrete and there's cement in the mortar mix that they use, I'm sure people are looking to different print materials. So I wanted to pull up the next example of 3D printing. I've got a whole folder here for Architecture for Thought. If I go into my Synth Arc, which is a division of Architecture for Thought, into my 3D printing, I've got everything in here. So I've got 3D printed architecture. Alquest is a famous 3D printer company. Perry, they have gantry style printers. Cobod, we'll open that one because they've got a pretty cool little thing on their website. So here's another example, but again, these are mortar printers, basically doing the same thing. Some of their extruders look a little different. The heads, the nozzles, some of them have fins on the side of the nozzles that allow every layer, every extrusion or beads to be smoothed out with fins on the side. They have very mini ones up on the screen there right now. But they've got some cool tools on this website that actually allow you to visualize some 3D prints. There's some texturing differences that you can do with 3D printing after it's done or while it's being printed. You can smooth it out with a trowel. So a lot of interesting textures and things like that. So the configurator, if you're interested, is the tool that you can come on, and they basically have the size of their gantry style printers and allow you to explore with some of the models that they have preloaded up. But that's not what I wanted to show. The next thing I wanted to show was a different printing material, and I'll see if I have them on file here. I should. It's going to be WASP, and so if I don't, I should, and I'll plug it in and save it. So let's just jump to it. WASP 3D printing. I'll just pull up their Tekla house. That's probably their most famous example. So what you're seeing on the screen now is Tekla. I forget what the acronym stands for, but it's essentially mud. So, or earthen, they call it. The idea for this, and I'll leave all these links in the description, is that you can actually use the mud or the dirt, the earth, the clay that is on site, and you mix it to get a consistency that's appropriate for the pump and the feeder to come through the nozzle and be printed. And we've got a little video here. So again, crediting this video to WASP, and their idea was, let's make this as sustainable as possible, as eco-friendly as possible. And so they're literally taking the dirt from the site, and as you can see here, they've got a digger. They're pulling the site into a mixer, they're mixing it, and they're pumping it, and they're printing it in place. So you're reducing transportation costs, you're reducing manufacturing costs for products, you're reducing in their sense, in this case, time for construction. So there's a lot of benefits to this, but of course there's a lot of drawbacks too, as it's still in a very high level research mode. There are, with printing in mud or earthen or cob, in some cases there are there are finishes that need to be applied. And so there are different lime mixtures that have traditionally been used to seal the mud. I'm not sure if they applied any sealing coat to this print. I think it was more experimental than anything. But something that was really interesting in this, not only the horizontal kind of corduroy layering texture, but the actual pleated texturing that they did was really cool. They also had, they did a print for, I want to say Dior or someone, a popular clothing brand, a fashion brand, and it also had like a similar pleated texture. So really interesting as a designer to be able to think about how you can start to use these textures actually as structural components. So that was another thing I wanted to touch on in terms of, okay, as a designer, let's talk about the things that you'll have to start to become interested in, or that will become more important in terms of designing, is material ecology. So material ecology, if you're familiar with Neri Oxman, is the study of materials that are available on Earth that can be used in architecture or products. So why that's interesting is, A, nature is everywhere. So we have the opportunity to either re-explore old knowledge of materials that just either hasn't been passed on or hasn't been explored very thoroughly recently with newer technologies. And I forget where I was, but I think I was doing an A-B type of thing. But the idea is that with the materials now, being able to apply them to new technologies such as 3D printing or other digital fabrication techniques, it does make you look at materials differently. So that is to say, Neri Oxman was looking at, I'm forgetting the word for it, but it's basically ground up shrimp shells of shellfish or shrimp, myro something. I'll have to look that up and put it in the comments. But when you grind it up and you add an adhesive component to it, it becomes very strong and malleable, flexible. And she has really interesting research and kind of structures that she's done printing in those materials. So I'll actually pull her up. But what I was saying was, let's just put her on screen, Neri Oxman. 3D printing So again, all credit goes to Neri Oxman for all of her research and her beautiful website. So she's got examples of printing in clay, or not clay, sorry, printing in glass, or I believe a glass-like material. Which again, as a designer, what I was touching on is that it's interesting because you have to either become interested or start studying material ecology, which is the study of materials, natural materials, chemically made materials, just basically materials that are, I'm not sure if that's defined under the definition of material ecology in terms of Neri Oxman's explanation of it, but synthetic materials, chemically altered materials, basically, I would imagine her definition would be more in the camp of natural materials. So if I can find the example where she was building with So here you can see she's doing cross-section studies of her 3D prints. So that was kind of like the part A, part B. I know we're on a huge tangent here. But if I go to her projects, I know she probably has, that looks like it might be an example of it. This is interesting for website design. I'll just say, it definitely makes you look at things differently. So I think I saw an example of it here. Very interesting website. So another one in terms of her material ecology studies was a silk pavilion, where she actually had silk bugs fabricate a structure with their own silk based on sort of a loose preliminary structure out of wiring or something that they would follow. And that was really interesting. We'll open that in a separate. So I think this is it here, biopolymers. So biopolymers, another great way to say, you know, basically an offshoot of material ecology. To be honest, I wasn't expecting to get too deep into Neri Oxman, but she does have like amazing work in this regard. So here she's talking about plastics, the tons of plastics that are obviously all over the world and in basically everything we eat and drink and our earth and our soil. And so here she's showing the printing process of the ground up chitosan, that's what it's called. So I think, I'm not sure if she has examples of actually grinding it and doing that process. I'm sure there's some research in here, but she's showing that it's a printable material. And you probably know, you've probably seen everything in terms of like 3D printed chocolate, 3D printed food, 3D printed meat. They're looking at now 3D printed wood. I mean, I've seen a lot of different examples of a lot of different 3D printed materials, but in terms of architecture, in terms of sustainability, and the tangent that we were on from printing with mortars and kind of cement-based mortars versus earth-based mortars, there's a lot of room for exploration if you're interested in design, if you're interested in architecture, if you're interested in sustainability and earth-friendly design. There's a massive opportunity now in terms of looking at these things more closely from an architectural perspective. I'll just really quickly play this. This is the silk pavilion that she made. So she just has, I think, some examples of the actual silk bugs. I'm not sure if they're moths or it's like a caterpillar of sorts. But really interesting, that they're eating the food. Here's a picture of all the silkworms like ready to go. Silkworms, they're worms. It just came to me right there. So, and then they show basically them spinning and fabricating preliminary structure, and then letting the silkworms kind of fill in the gaps, which, in this case, it's letting nature build architecture, which I know, is a concept that extends very far back. But it's great to see that it's not only being re-explored as sort of a fantasy type genre, but it's actually being explored as a realistic approach to fabricating architecture. So the other thing that I wanted to say, and I'll just leave this up on the screen, was in terms of, I was doing an A-B type of thing, and we got sort of into the material ecology part of it, talking about the different materials that are either natural made or synthetic. I mean, again, just to clarify, I don't think Neri Oxman's definition of material ecology is going to include anything that's extremely synthetic in terms of chemically altered. But I mean, I'm sure there's got to be some allowance for adhesives and things like that. But even if there's not, that's still a huge area of study, obviously, looking into different materials that can be printed that are not natural made. But the other end of that was structure. And the idea that 3D printing is, it's affording us some new opportunities to leverage technology to maybe save time with some components of architecture. But where I'm really excited about it is the idea that we actually have an opportunity to shift the structural design back into architecture, which, I know the idea of architecture is that it's a cohesive whole, right? It's a composition including all disciplines, and it has to be well coordinated, and it's an orchestra between everything, blah, blah, blah. That's great. And in previous episodes of this, we've talked about the idea that architecture, or architects specifically, they're supposed to be the quarterback, right, of all the different processes that go on in architecture. Once you hit that design development and you bring on the mechanical, electrical, plumbing teams and structural engineers and any other consultants that are involved in the project, you are basically from that point forward organizing and composing systems to work together. And I think that's why people love Zaha Hadid's design so much, is not only do they look cool, but they look like that for a reason. I shouldn't say for a reason. I think an effect of her designs allow very efficient layouts for all disciplines, all trades. So it always reminded me basically of when you'll see network systems that are really well bundled. So I'm talking about like cable, Ethernet cables coming from a data center or something in an office building, when you would see literally like all the lines that are together, and then they would bifurcate and kind of split and go their ways. But a really efficient bundling job. You can see how a mechanical ductwork layout would follow that, electrical conduits, and then lighting. I mean, when you start to merge all of these systems, you get something that I'm calling Synthitecture, which is like the next evolution of architecture. But I think a lot of people have started to attempt to merge a lot of these systems into unibody components. So if you've followed this channel and if you've heard me speak before about any of this, it's not too dissimilar from what we're seeing happen in auto design, and I would say in product design. We're getting fewer, more complex pieces, components. And what happens with that is it forces the architect, if we are still going to be the quarterback in all of this, it forces the architect to broaden their scope of organization and begin to integrate all the other disciplines into singular designs. And so what I mean by that, for instance, is let's take the unibody car design that I think, with Tesla is a pretty prominent part of a lot of their designs, is basically what I was saying before, and it's not a new concept. I know a lot of other manufacturers have done this, but they're trying better to integrate structure and frame and any other chassis pieces that can be basically molded into one piece. So let's take that and apply it back to architecture. With architecture, we know there's thousands of pieces that make up a building, right? I always refer back to this. It's like a famous, or I don't know if it's famous, but I liked it. It was an advertisement in some architectural magazine, and I had seen it online and a lot of different other forums also. But the advertisement was a Beetle, like a Volkswagen Beetle. It had looked like, had been like exploded, taken apart, with all the separate pieces, and literally thousands of pieces kind of spread out on the floor. And I think there's a lot of famous artists that kind of do art like this also. They'll take, basically an object or an item or an event, like let's say you're a chef and you bake cakes, and it'll take the chef and lay him on the floor and then basically lay all his tools next to him. You can see how many components and parts and pieces it actually takes for that entity to fulfill their task. So same thing with this beetle being exploded on the ground, being able to see all the parts and pieces. It was an advertisement in an architectural magazine to basically say, are you still building your buildings like this? If you are, there's better ways to do it. And there are. I mean, or at least we think we've gotten to a point where we have started to merge a lot of systems into unibody type systems. We have our curtain walls, we have our metal panels, we have our roofing systems, and then all your interior components. That is to say that manufacturers have taken a lot of the responsibility from architects in terms of design and integrated them into their systems for waterproofing, solar heat gain responsibility in terms of glazing technology. You can see how it's basically what's happened to all of our technologies being integrated into the iPhone. Things are starting to merge, things are starting to synthesize, and hence that's the prefix of my concept for Synthitecture, which is like the next evolution of architecture. Is basically we are ready now to take the efficient systems that have come out of the previous generation, merging all these items into separate components, the curtain walls, the metal panels, and we are ready to start merging those now into each other. And what's affording us the opportunity or ability to do that is 3D printing. So this is sort of a very long way of saying, I'll jump back into my screen here. Not sure where we left off, but that's basically a long way of saying, if I could bring back up the examples of WASP's 3D prints, they are looking here to use their wall components as wall, as roof, as multiple components in the building that can be as structure, that can be pieced together or printed in place. Another idea of this is that, yes, you can actually print these pieces and bring them on site and put them together. So for that instance, and to kind of merge into that concept, I will bring up branch 3D printing. Branch technology, freeform 3D printing. So really interesting. This one leans more on plastics, I believe, for the printing. Here, everyone's got a video on their web page, that's great. But this is showing an example of basically a smaller 3D printed arm and how they print in components and then merge those components either on site. So they have examples of milling or printing wall panels and then finishing them and putting them up on the wall. That's sort of a more a more elementary method of what we were just talking about. But I do know, I mean, they basically offer the ability to print components as well. So there was another video that popped up here from Branch. Let's see if I can scrub through here and find something of the sort. So if you're familiar with, I'm not really seeing any great examples, but here's one. So again, these are just facade systems, but here's like a system that you can see where they're actually creating the webbing to produce the panel that has the insulation in it, integrated clips on the back. It's basically thickening the wall system, and then if that can become structural, you're really entering like a new realm of merging the components together. I think another good example of that is Zaha, Hadid's 3D printed bridge. And so this is called Stridus. Not sure if I'm pronouncing that right, but this is another good example of the, don't want to watch an ad. Another good example of the 3D printing becoming structural. So let's see if I can pull this off out here. Skip that. So great video. If you haven't seen it, check it out. I'll leave a link to as many of these things as I can in the description. But so this is their 3D printed bridge, and the very interesting thing about this is that it basically works on friction only. So there are strength through geometry, they call it. These are all pieces. They found the tension points, they found the center points for where they would bifurcate, and they basically 3D printed all these separate components to fit and nestle together so that they did not need any structural fasteners or binders or anything of the sort. So you can see for this they used a 3D a multiple access 3D printing arm so that they can actually get that fanning. Typically in 3D printing you are limited with gantry style printers to just printing layer by layer horizontally, but with the arm, the 3D printing arm, robotic arm, you have the ability to move in multiple axes, meaning like vertical also, while you're printing a horizontal line, and kind of gives you the ability to move up while you're moving horizontal, is what I'm trying to say. Which allows them to get those kind of fanning pieces, which in this regard is really important for those stresses to kind of be following the arched pathway of the actual structure. So this is really neat, and for me, I'll just kind of pause it on here somewhere. I mean, look at that, that's great. These are all the components. I don't know if this is all of them, but it's just showing you an array of the components that are printed on site. And the interesting thing about this is the idea of mass customized manufacturing comes into play here, where as long as you have all these pieces in digital format, the printer doesn't necessarily mind how different one piece is from the next. And so you're able to print a multitude of various pieces, one after another, basically the same time it would take each one. Maybe some that are more complex or larger take slightly longer, but the idea is that you're basically printing all of the building components and then shipping them to the site. So in this case, the eco-friendly nature of printing and shipping it to the site is still there, but theoretically you can print these on site. I think they're going to argue that there's just a lot more control that you can have in a shop to print these, which is fine. But again, I digress. The idea is that mass customized 3D printing or manufacturing is a possibility. You are integrating wall components, architectural components, finished components, exterior cladding. You're integrating that with structure, and then on top of that, you can imagine, if this became more complex or not, as is, these structural routes become routes for mechanical paths, electrical paths, plumbing paths. And there's a lot of area obviously that has to be studied in terms of that. Meaning, I know there's stresses and there's allowances for deflection that, may be fine for structure, but may not be okay for plumbing. But the idea that these components, componentized 3D printing, can house or host multiple trades and disciplines is a really exciting one for me, at least. So I think in terms of especially, mentorship for emerging architects, if there's any young architects listening to this, if there's any designers who are in academia and they're curious for different routes that they can go, if they don't want to just be following kind of the traditional status quo for printing, or not printing, for doing architecture. I'm wanting to promote that there's a lot of different routes out there that architects can take. So I was just going to snap back to the kind of landing page for Icon, because they've got some beautiful imagery on here that showcases what they're looking to do with this technology. If you're familiar, they recently hosted a competition. I think it was called I-99. The idea was, or the challenge for the competition was to design a home that can be built with their printer for under $99,000. And the competition was great. It produced some really interesting results. You can see, I think probably some of them are integrated into this model that they have here. And the cool part is, there's some homogeneous kind of effect of using the same print material and kind of these popped on roofs. But you see the diversity and like building shape and form, which is pretty cool. I don't know. I think it's kind of an interesting topic to be explored. But so we'll wrap this up here. This is basically a very, very high level overarching conversation about 3D printing in architecture. Probably did not cover nearly as much as I would have wanted to. Again, this was sort of off script. I just wanted to kind of talk freely about the different things that I've recognized happening in the world of 3D printing. And if I can sort of recap, we'll go through, sort of the standard material that's being printed with right now is a mortar mixture that typically has lime and cement, sand, and there are explorations into printing with different materials. We have someone come on here. Oh, hey, how's it going, Akil? We've got someone that just popped on who is also very interested also in the future of architecture, so I think these topics are probably very important to him as well. But so we were saying, you're starting with the mortar material. It's a very common print material, moving into more eco-friendly print materials such as earthen, so clay also as a print material. And then from there we went on to discuss basically the opportunities that some of these materials get us, or just 3D printing in general give us from a design perspective, in terms of, we were talking about texturing, curved walls, which I didn't touch on too much, but again, with some of the newer printers, I know Icon's Phoenix, I believe, that's what they showcased most recently at one of their events, was the ability to print like overhangs or arches, to begin to print more dome-like structures, to, again, which transitions us into our next kind of topic, was integrating structure into your prints. So combined with the idea of texture, you are talking about structure. Gaudi experimented a lot with like inverted parabola, and so I think that's why we're seeing a lot of that with the print materials, because you're basically taking a fluid-like material, and it's extruded and then literally extruded over the course of time to produce a structural shape. And these most efficient structural shapes are tending to be like parabola type dome structures. Really interesting side note, and I hope to do an episode on this in the future, is Musgum mud huts. So these are mud hut designs that are built in an area of Africa by a certain tribe that are literally built by hand and mud. And I'm not sure if it's a cob mixture. So cob is when you take the mud or the clay, earth, and you mix it with hay, straw, and that becomes the binding element. But either way, they're these beautiful dome-like structures that are basically being replicated with a lot of the 3D printers that I've seen, even for some of the 3D printing challenges and competitions that we've seen for printing on the moon or on Mars. These dome-like structures are always coming into play. So that's interesting, really interesting to keep your eye on. That's what we saw with WASP printing with their mud structure with the kind of pleated exterior. So you have the corduroying beaded texture combined with the pleated kind of folding ribbed exterior texture to create the dome, and the ribbing or the pleated gives it some extra strength. So then that topic then took us into, and then we had a huge sidebar on there with Neri Oxman, but that structural topic then took us into, I know, sort of self-promoting the concept of synthitecture, or the merging of disciplines and products. I won't go on too much of a side tangent right now, but again, if you've seen any of these videos, you know I talk a lot about how architects are basically becoming product specifiers, specifying different manufacturers' products. And you know, for me, when I was making my way through the ranks in terms of being a designer, to a senior level designer or a senior level architect, project architect, it felt more and more like I knew what was coming down the line in terms of needing to find a material or a product to fit a design. So it starts to change the way you think about designing, just by knowing what materials are available, what fits the client's budget. And it was really upsetting because I thought when I was especially in academia that, you know, I was going to have basically the same freedom that Gaudi had to produce what he was doing. And it's not to say that we don't, and I definitely forced my way through it, through just my knowledge of basically curved framing to produce Zaha Hadid similar, you know, type architecture. But then I found 3D printing and discovered that it really has the ability to basically turn the architectural profession either back on its head or back on its feet, in terms of putting the architect back as the master builder, as the designer with the vision, who is integrating all the different components of a building, of the utilities, all the systems, designs, and producing truly a cohesive whole with either a unibody part or, again, componentized parts to create a larger body. And then we looked at some of the examples through Zaha's striatus bridge and some of those other examples. So, like I mentioned, that was just the overview of this, so I'll timestamp that if anyone wants to refer back to it and get like the 1 or 2 minute synopsis of everything. But as an even overarching kind of conversation to that, these are pretty theoretical level topics. They are being studied at a lot of universities, so it's not to say that they're not happening. You know, from a more philosophical perspective or psychological perspective, I think, you know, moving through life, it may feel like you think things are going to move pretty quickly in terms of technological shifts. And I know with AI and a lot of the digital fabrication, things can feel like they're moving really quick sometimes. A lot of the new technologies that will pop to surface, but 3D printing has been happening for a very long time. So to see it at the state it's at right now in terms of actually printing buildings or printing components for buildings, it just shows me that there's still a lot of work left to do. It's still pretty much in a high experimental state, but it doesn't mean that it can't become a very prominent avenue in terms of design and architecture. So I'll leave it with that. Again, this is LEAP, League of Emergent Architectural Practitioners. I'm Stephen Corliss, your host and mentor. Thanks for joining, and I hope to see you next time. Bye.